Welcome to this session. In this session, we are going to derive the error formula for quotient of 2 quantities x and y. So let's x by x epsilon sub y sub x be the exact approximate and similarly let y by y and epsilon sub y be the exact approximate and error magnitude in the quantity y respectively. So then now from definition of error, when we have exact and approximate values, this implies that error in x is x minus by x, while error in y is y minus by y. Now, this implies that by x is x minus error in x. So quality equation 1. This implies approximate value of y is y minus error in y. Call this one equation 2. So equation 1 divided by equation 2 gives so by x over by y equals to x minus error in x over y minus error in y. Then this can be written as x minus error in x divided by y into 1 minus error in y over y. There's nothing I've changed. Denominator is still the same. Now, we can say approximate value of x over approximate value of y is x minus error in x over y times 1 over 1 minus error in y over y. Now, this can further be written as error in approximate value of x over approximate value of y is x over y minus error in x over y, and then you multiply by 1 minus error in y over y raised to power negative 1. So which tells us that by x over by y is given by x over y minus error in x over y. And then this one, since error in y over y is having a magnitude less than 1, then we can expand this one by binomial theorem. So it should be 1 plus error in y over y plus error in y squared over y squared plus error in y cubed over y cubed, and then plus other several terms. So remember, we are using binomial theorem, which when we have 1 minus h raised to power -1 gives 1 plus h squared plus h cubed plus h power 4 plus many other terms, provided the magnitude of h is less than 1. And you see here, error in y over y, magnitude of this quantity is less than 1. So that's why we have from here to this point. So next will be now to expand this. So approximate value of x or approximate value of y is x this by this, and then plus x error in y over y squared plus x error in y squared over y power 3 plus x error in y cubed over y power 4 plus other several terms. And then, so minus error in x over y times 1 is minus error in x over y minus error in x times error in y divided by y times y is y squared minus error in x times error in y squared. So y squared times y is y power 3 minus error in x and then times error in y cubed divided by y power 4 minus other several terms. Now, to first order approximation, all the product of error terms and any error term with power more than 1 will go to 0. So to first order approximation, we neglect higher order error terms and their products. So that means that this will be 0, this will be 0. Also, the terms here will be 0, here will be 0, this will go to 0, this will also go to 0, and also these terms will be 0. So that I will have bar x over bar y. That'll be approximately equals to x over y plus x error in y over y minus error in x over y. All the other terms have gone to 0. Now, which means x over y minus bar x over bar y is approximately equals to error in x over y minus x error in y over y. So this is defining, remember this was y squared, so this is square. This is y squared. From here, this term, it is x error in y over y squared. So this is square. So this true quotient minus approximate quotient defines error in the quotient. So it'll be approximately. Now this we can put under 1 LCM, y squared So y error in x minus x error in y. So therefore, error in quotient x and y will be y error in x minus x error in y over y squared. So this is the value or the formula to approximate the error in the quotient of x and y. Now, relative error in the quotient will be error in the quotient over true quotient, which will be approximately y error in x minus x error in y over y squared divided by x over y. So relative error in x over y is approximately y error in x minus x error in y divided by y squared times y over x, reciprocal of this. Now, y will cancel one y here, so that we'll have relative error in x over y. It's approximately y error in x minus x error in y. Now y times x is xy. This can be written as relative error in x over y. It's approximately y error in x, xy minus x error in y, xy. So which means y and y cancels out, x and x cancels out, i.e. relative error in x over y is approximately error in x over x minus error in y over y. And from definition, error in x over x is relative error in x, error in y over y is relative error in y. So relative error in x over y is approximately relative error in x minus relative error in y. So we are saying that the approximate value of relative error in x over y is difference between relative errors in x and y. Thank you.